Thursday class, we discussed about elasticity, lecture 1, and today, see lecture 2. Okay? In this, we deeply discuss about stress and strain. Okay? So, in see, actually, what is going to happen now? For example, if there is a rod, okay? Now I am going to apply a force on this. If I am going to apply a force on this, automatically one more force is going to be applied, right? This is called as external force. This is called as internal force. So, ಇದನ್ನೆಲ್ಲ ಬರುವಂತ ಇದನ್ನೆಲ್ಲ ಬರುವಂತ pressure. So, pressure is equal to F external by area, and stress is equal to F internal by area. So, this is what the fact actually what we have discussed in the previous class, right? And what is the definition we can use nowadays? So, finally we can say stress is equal to internal force by area. Okay, this is what stress is equal to, and pressure is equal to external force by area. Now listen carefully. If I want to see stress, what I should do? I have to deform the body. For example, this is the body what I have taken. In last class, what we have discussed, I have just applied a force here, and this part was fixed, right, and applied a force here. Because of applying of force, the body has come down here, and on this I applied external force. This gullugulla. In your internal force act again it is going to come back here, and idinala varada stress on a surrogate. That means if I want to find the stress, definitely I have to deform the body. On deforming, what happens? I can able to feel the stress. So if I am deforming the body, that means its dimensions are changing, right? Whenever the dimensions are changing, the change in the dimensions is called as what? Strain. இப்போ உங்களுக்கு புரிஞ்சிச்சு. நான் ஸ்ட்ரெஸ் பார்க்கணும்னா நான் பாடியை டிஃபார்ம் பண்ணிடணும். நான் பாடி டிஃபார்ம் பண்ணாதானே ஸ்ட்ரெஸ் எவ்வளோன்னு கண்டுபிடிக்க முடியும். If I am deforming the body means the body is getting changed in its dimensions. The change in its dimensions is called as what? Strain. So strain is equal to what I can say? Change in dimensions by original dimensions. Now I hope all of you understood now why strain is being coming. Because of observing stress, I want to change the body. Whenever its dimensions get changed, now I am going to get the strain. Where strain is equal to change the dimensions to the original dimensions. Right. Now come on, let's go for the very important law called as what law? Hooke's law. So what is the Hooke's law states for us? In elastic limit, the stress is directly proportional to strain. So, stress is equal to, if I release the proportionality constant, I will get E, where E is called as modulus of elasticity. Right? So, that is what you are. E comes out with it. Modulus of elasticity. Now see, here this stress is to be taken as what's up? Y is equal to this E will gives you what? M, and strain is going to give you what? X. So Y is equal to X means what line it is going to be? Straight line, right? So if I draw a Y axis and X axis, how do you know Y is equal to Mx means what? It is going to be a straight line like this. So in place of Y, what I want to put? Stress I want to put, and in place of X, what I want to substitute here? Strain. So stress on Y axis, strain on X axis, and the slope is going to be what's Young's modulus. This is nothing but not Young's modulus, just elastic modulus. Okay, so this is how we are going to plot the graph for stress versus strain. This is just a basic idea so I'm just going to give you, and in further process for different materials we will be having different types of graphs. We will see there. Now, just you can make a note of this one very clearly. Okay, now let's see what are the different types of stress. There are two types of stress, and in strain there are three types of strains. And while coming to the stress, we are having normal stress and tangential stress. The very first one is called as what stress? Normal stress, tangential stress. And if you are going for the strain, the very first strain is called as longitudinal strain. Longitudinal strain, volumetric strain, shear strain. So this is how we are going to classify this strain. Okay, so make a note of it, and further I will discuss in deeply what is a normal stress and tangential stress. Later we will go over the strains. So let's see what are the different types of stress. The very first stress I already said you was about normal stress. Actually, what is the normal stress? Nothing but force perpendicular by area will gives you the normal stress. For example, if I take a body and I am applying a perpendicular force on this will result in a perpendicular force internally, right? This is external force, internal force. If it is like this means this also will be like this only. Hence, this type of internal force is called as what? Internal perpendicular force is called as what? Normal stress, which is perpendicular to the surface. So that gives us the normal stress. Next, if we go for the tangential stress. In this tangential stress, if you take a body, fix this bottom part, and if you apply a force like this, then what happens now? See, there is a result of change in some angle here. Now, idinala varada tangential stress, which is a parallel force. Okay, parallel force. Now, இப்படி நமக்கு உள்ளுக்குள்ள இந்த force இப்படி வரலாம் போனது இல்லையா? இந்த force பேர் தான் இது என்ன force? Parallel force. So, tangential stress is equal to F parallel by area. For example, I ask you a question. There is a body of mass m. On this, I am going to apply a force F. Okay, and if this force F is what making some angle called as theta. Yeah, with horizontal. So again, it is going to make an angle called theta. This is called as cos theta. This is called as f sin theta. ಇದನಾಲ ಬರ್ತದ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್. ಇದನಾಲ ಬರ್ತದ tangential stress. Oh, you understood now. So just make a note of it very clearly. Later, we discuss about the strain. And you all know what is the definition of a strain. Strain is nothing but change in dimensions to the original dimensions, right? And I already said the very first one is going to be what strain is a longitudinal strain. That is equal to change in length by original length. change in length by original length will gives you the longitudinal strain. Suppose sir, if there is a body here, area equal பண்ணுங்க, area கூட நான் பேசவே இல்லை, only I am talking about length. If I am going to apply a force like this, it is going to expand like this, right? Now there is a change called as what? Delta. Here it was expansion in length, and fix it. Always you should fix it. Next, I fixed it, compressed. Now, this is how the body is going to be changing. Delta length, right? Now, if you see here, this is going to be also called as what? Strain. The change in length by torsion. Here, the change in length by torsion. Here, increase in length will take place. Decreasing in length take place. That is what your longitudinal strain. And next one, we go about volumetric strain. Volumetric strain is nothing but, for example, if you take a ball here, say this initial volume is V. If you compress it, what happens now? This will be the final volume, right? This will be the final volume. So what you can take now? Strain is equal to change in volume by original volume. This is the change in volume. See, so this is the change in volume. So delta V by V, right? And anyhow, remember that it's going to be dimensionless quantity. No dimensions, no units, because delta L meters, length also meters, meter cancel, so no units for this, right? The last but not least, we discuss about the shear strain. Shear strain. What is the shear strain? And let's see. I said to fix it, and I said to apply a force. On applying the force, it will go like this. There is an angle called phi, and here there is a small displacement called as x. Small displacement x. Now you take your tan phi from this right angle triangle. If you take tan phi opposite by, say this is having a height called h, so tan phi is equal to x by h. So this is what your shear strain. And if angle is very small, means what is your tan phi comes out to be? Phi only. So phi is equal to x by h. Okay, this is the way how you want to represent your shear strain. Okay.